talk is by Trevor Norris of NodeSource, who's going to talk to us about the state of Node. So, Trevor.
Thank you very much. Hello, everyone. Thank you for being here today. I'm with NodeSource. I'm a Node core committer. You don't really need to know anything more. Let's go get started. State of Node. Oh, that's an ambiguous topic. So very ambiguous. So we're just going to address new features that have come in 0.12, breaking features, things to look out for, things you can take advantage of as you're upgrading from 0.10, and also I'll address slightly what's coming after 0.12. Now, since we've been in 0.11 for over a year and a half now, there are a lot of new features. Fortunately, there are not that many breaking changes, but there are a lot of new features. I tried to only hit the highlights during this talk. I believe that'll make it easier. Now, I am happy to accept any questions about an individual slide during that slide. Any other questions, please hold till after. I'm going to save 5, maybe 10 minutes for questions afterwards. You can go ahead and ask me then. Now, streams. Streams 3. Oh, real quick. As you can see, there's a hashtag. On every single change, I put the hash of the commit that introduced that change, so you guys can look that up later, read the commit log, and exactly what's going on if you want to. So, Streams 3. Paraphrase from Isaac, Streams 3 works the way people thought Streams 2 should have worked. So, just keep using Streams the exact way you thought you should have been using it in 0.10, and everything will work fine. Now, another API that was introduced to streams, writable streams specifically, is cork, uncork, and writev. Now, this can only be really taken advantage of on the Unixes. But what happens is when you cork a request, here, let's just jump to the example. It's much easier to explain with examples.
Oh, there you go.
Yes, yes.
Can we back up a slide, please?
Sure.
So when you talk about Streams 3 works the way people thought Streams 2 should have worked, could you elaborate with some more concrete examples of what that actually is?
All right, let's see if I can put this concisely. It mainly has to do with the way old streams, the Streams 1 and the new streams, the original streams implementation was push-based. You'd say event on data, and then whenever data arrived, it would just throw data at you. The new API, you do on readable, and it's basically telling you, hey, there's data, go ahead and read it whenever you want. And within the readable, you say .read, and it'll hand you data, right? Unfortunately, there was some, in Streams 2, there was a really hard delineation between both paths. The change that was made was that in Streams 3, the push-based API, the old API, now uses the new API. It just pushes immediately, right? So as soon as it gets a readable event, it will do a read and then send that to the user. Where before, it literally had an entire different code branch it would follow for each thing, and so it was much more difficult to intermingle like on data and on readable streams, right? Now, on data actually uses on readable as well. It just then receives it immediately. Does that make sense? Okay.
I think it would probably be better with an example, but we can chat after.
Okay.
I don't want to derail your talk.
Yeah. Don't worry. Plenty of people find the Streams API complicated, myself included. It is extensive, ridiculously extensive. I still don't know how to use the underscore functions, like underscore read, underscore write. Like, yeah. I stick to, well, being that I mainly write in C and C++, I'm totally fine with callbacks and passing messages and whatever. So, yeah, we can talk about it, see how far we get. Maybe I'll learn something too. In fact, I probably will. Now, moving on, the chunk, or cork, sorry, not chunk, cork. When you use cork, you tell write not to write out immediately, but to write out when you call either uncork or end, right? So net specifically, here you can see we're corking, we're writing out a couple chunks, and then we're ending. This will send the data. Now, if I remember correctly, because we've gone through a lot of iterations, like I've said, if you don't call uncork or end right here, it won't send the data out. So if you do another asynchronous event, it will keep the data buffered until you've corked or ended the data. Now, why this is useful is when you are, first let me explain a little bit of the mechanism. The reason it only works on the Unixes, I think I just combined it singular and plural, but you guys understand what I'm saying, is internally at the kernel level, it will buffer up a lot of small chunks of data and then pass that to the kernel and say, write all these little chunks of data out as one big continuous chunk of data. And so the TCP connection doesn't have to do a lot of back and forths for every single TCP packet, right? It just fills up the TCP packet and shoves it down of how many chunks you've written out. One place where I see this very useful, especially with HTTP, is rendering templates. That seems to be a very, very common thing today using Node. And a lot of templates have this streaming mode where basically it renders a small amount of the template and it sends it out immediately, right? Well, unfortunately, a lot of those small chunks are like a quarter or less of the size of the entire TCP packet. And generally, at least I really hope so, and I'm going to get on my little pedestal right now, your template renderer doesn't take more than 10 milliseconds to complete, right? So those 10 extra milliseconds between writing the first and writing the last are actually going to save you time, and you'll be able to do more requests per second because you're saving that round trip cost and that syscall cost. So moving on to net. I think HTTP is after this, right? Yep, all right. So let's jump to HTTP and I'll come back to net. All right, so chunked encoding defaults to use writev, which is the cork uncork thing, right? The difference is that it will automatically uncork your data. Like if you don't call end at the end of the write, or at the end of the synchronous block, it'll automatically uncork at the end for you if you don't call uncork or end. So when you're doing a chunked write, it'll automatically cork the data for the synchronous execution time and then send it all down the stream. We found that this has massive performance improvements. Now massive, I mean like 20 to 40%. For writing chunked encoding, chunk encoding really bites in terms of performance. The client doesn't know how much data it's supposed to be receiving, so it just has to stand there with its arms open and just kind of like, I think I'm just about there. No, I'm not really there yet. Is it? And then it has to do like the HTML actual parsing as the page is coming in, and it looks for the last, the /HTML tag at the end. It's like, hey, I think I've received everything now. It's a total pain in the butt. When you can set content length, do it. So by using writev, we can help that process by writing out as much as possible in per synchronous code block. Request.flush, that basically allows you to flush the headers immediately. This is useful for cases when you want to open up a connection to, or a connection has been opened to you, and you know you're not going to, you're not going to send the body immediately. Usually, the headers are not sent. By default, the headers are not sent until you've sent body data. But if you know that you're not sending any body data immediately, but you want to get the headers down immediately, you can run request.flush, and it'll immediately flush the headers down to the client while you process the body content in the background. And the last one is message.raw headers. A lot of people, people on the issue tracker were discussing how capitalization and whatnot actually mattered in the headers themselves, right? People were abusing headers to do specific things, and while technically not part of the standard, they needed that non-standard functionality. And so we introduced message.raw headers, so you can extract the headers exactly as they were received by your server or your client. That way you can parse those in the case that you need it. Hopefully you don't. Hopefully the services you're using don't MIF the headers in a non-standard way, but it's there just in case.
I think I must have missed.
Mike. Right here.
All right, so I think I missed it. But writev is a buffered write or a forced write? What's that?
writev is, well, writev basically blocks any write syscalls until either the end of the synchronous block, at least for HTTP, until the end of the synchronous block, or you end the connection.
So writev is when it's going to be buffered, right?
Yes.
Okay, and then if you do a normal write, like
Well, no, write is always corked for HTTP for chunked encoding.
okay,
Okay.
I'll have to come back to that. No.
Yeah. We can talk about that afterwards too. All right, now moving. Yes.
Quick, should that be response.flush?
Mm-hmm.
The second one. Request.flush looks weird. Should that be response?
Possibly. Yeah, very likely.
Okay.
Yeah, you're right. That looks weird. Okay, I'll change those before I hand out the PDF. Now going to net. Okay, yeah. That now makes sense. Let's go to net. Two things. One is we try and bind to IPv6 by default now, if it's available. If it's not, we fall back to IPv4. But since we have, what is it called, like dual stack or whatever, basically, by binding to that, your node service can now accept connections on IPv6 and IPv4 by default. Okay, so that's coming in 0.12. And also now this is, it's kind of weird. It's a DNS event, but the event handler is on net, right? So lookup is a DNS event. Basically what happens is you like say connect to this server, intuit.com, right? And first it has to do a DNS lookup and say, okay, what's the IP? Now the lookup event will fire as soon as it knows the IP address, but before it's actually gone out and made the connection to the remote server. I don't know why anybody would use that, but I'm sure people would because it's in there. And it probably got in there because somebody requested it. So have fun with it.
Thank you.
All right. Glad to hear somebody will. All right, crypto. Yeah, a lot of things have been added. RSA encryption and decryption, elliptical curve, Diffie-Hellman, custom, that thingy. I don't touch crypto. I leave all that to Fedor. Like he's insane. So, lots of new crypto stuff, and also we've been making sure crypto stays very secure. I know we backported this to 0.10 as well, where SSL v2 and v3 are disabled by default, and you need to explicitly enable them with a flag. So yeah, security, we try and keep on top of that. Fedor, again, he's amazing. When Cloudflare put up their challenge of being able to extract their private key from the server, he was the first one to complete the challenge. So he is definitely a good man to have on our side, reviewing our security code. All this stuff will be great. It does need to be performance optimized. We'll get into that later, but at least the functionality is there now to test, and we can keep it supported. All right, URL. Small change that went in recently. Our URL parser didn't follow anything specific, so we changed it to follow the whatwg specification. Right? So before, here's the URL you're parsing, right? And before it said plus isn't a good character. That's stupid. So it went ahead and changed it so the host was good.com, and then it actually parsed out the path as evil.org. I don't know why it was doing that, but it did it, right? Now, see, technically the plus sign isn't an invalid character via the whatwg specification, right? Like, I think the asterisk is and a bunch of others, but plus, for whatever reason, isn't. So it now parses it out following the whatwg spec. So do expect some differences that way for weirdly formatted URLs. And we're going to try and keep up with those specifications as well. We just find it's easier, the test suite's already there, check's already there. Just makes life easier instead of trying to explain to people why we're doing some crazy thing like changing the actual, why did we do that? Whatever. All right, ICU, internationalization. A lot of people, man, this has been a long time coming. Thank you, Steve. Oh, there you are, hey. Has put a massive amount of work into this. I mean, like a ridiculous amount of work. So I think that second bullet point should have been first. I'll hit that. So coming up in 0.12, all distributed binaries will have small, quote unquote, small ICU, or basically English support built in, right? But the source code will still build without ICU by default. The reason is a lot of the times our tests, like ICU, it takes as long to build ICU almost as it takes to build like the rest of Node. And most of the time, we're not testing internationalization, but it's really easy to configure. Thank you again for like, he has many configuration options for how you want to configure it, how you want to put it in. Also, I don't have this in there either, I don't know why, but we will be distributing the actual DAT files with like a small instruction guide on how to use those. As you can see on the second one, the first one, which again should have been the second one, you can side load those DAT files as you're executing Node, and it'll actually load the internationalization data at runtime. How freaking cool is that, right? So, yeah, internationalization by default, rock on. Yeah, can you stand up and like wave or something? I'm serious, this dude has done thousands and thousands of lines of code to get that working.
Very good question for those of us who don't know. What is ICU?
Internationalization, like say, oh, here, you answer it.
So I'm Stephen Loomis, IBM. ICU is International Components for Unicode. It's an open source library. It underlies a large array of different software, everything at IBM and a lot of other places too, and open source projects. And also the Intel, just a note, is ECMAScript 402 API. This is the capital I NTL object. It is, I didn't implement that. That's in V8. Mm-hmm. But what I was trying to do here is get it on by default. Yes. So it becomes part of the core Node available APIs. So anyway, and I work on ICU. That's my main day job.
Yeah, that is his life, literally.
Can it help me implementing the Turkish problem, the Turkey I problem, for internationalization?
Turkey I?
The
like
Turkey
an
problem.
Eyeball? An eye? What?
Okay. It's about internationalization.
Then yes. If it has to do with internationalization, I'm just going to say a distinctive yes. It will help in some way.
I hope so. I haven't found anything in Node.js right now, so.
Yeah, no, it has, I mean, as far as the INTL object, you like say INTL, you give it some region or whatever, and then you say like, I want a date time format for Turkey, right? And then it will like spit that out. Or I want money printed in however they do it in Britain.
It's about the uppercase, lowercase I, which is the first in Turkey, language and other language, but this is the known problem.
Okay.
So I can talk briefly about ECMAScript 402. So the ECMAScript 402, which is a spec coming out of the ECMAScript TC35, the three things in that are datetime formatting, number formatting, and collation. And collation especially takes a lot of data, a lot of code. It's much more difficult to polyfill in a pure JS way. Possible, not impossible. What you're asking Turkish I, that is probably something that should be considered as a future language specification. There's a bunch of people looking at that, and doing this will help make that work in the future. but not at this exact time. So, file ticket. Let's talk about it. Go to what's it? itninjs.org. I forget the site that's discussing this.
Yeah. So yeah, it's the reason we're only distributing the English by default is because we wanted, in order to be able to sideload, we need like the compiled code in there to be able to load a language, and you have to load at least one language for that to work. So we're just throwing in English by default. And the reason we're not doing all the languages is because it more than doubles the size of the downloaded binary for Node. So that's why we're leaving that to be sideloaded. And to be honest, a lot of companies I've spoken with have their own Node builds anyway, with their own specifications on how to do ICU. And so that's the reason why we decided to leave the build without. Another reason why we decided to leave the build without ICU by default. And it makes our life a whole heck of a lot easier in terms of needing to bundle even more stuff in the deps folder. Buffer. Now, I'm sorry, like, Buffer's my baby. I rewrote it from scratch pretty much. Well, not scratch, but most of it. And I might be a little biased on covering this simply because I know the most about it. Simple one, buffer.fill now returns an instance of itself. So new buffer.fill 0 returns the buffer that you just created. That way you can one line a 0 filled buffer instead of like doing var b equals new buffer, next line b dot fill 0, right? Just it saves you a whole 4 characters or whatever. But it makes things simpler. And it accepts multi-byte strings. I don't know why, I just decided that being able to fill only with one character or one number was inadequate. So you can enter like ABC, and then it'll repeat the letters ABC n times until the buffer is filled with those characters. Be warned though, if you put in a Unicode character, like say you put in a Unicode character that has that uses 2 bytes, and you fill an odd size buffer, the last character is going to be borked, right? Because it's just going to copy the first 2 bytes of the Unicode character into the last spot on the buffer. But I wasn't too worried about that, so I didn't deal with it. I didn't even know how to deal with that. Like, not fill it, whatever. Slow buffer, and I don't know how many people even knew about that, but like it's not global by default. You have to do require buffer.slowBuffer. Beforehand in 0.10, internally, buffer would like there was actually 2 buffer instantiations, which was freaking nuts. You had a C++ class that would instantiate a function template, and that was a slow buffer, and then you had a buffer, which was instantiated in JavaScript, and it was just a mess. So what I did was now buffer, for small buffer allocations, it'll actually give you a little slice of a larger buffer because it drastically increases performance to do so. Now slow buffer, I decided to keep it around and repurpose it and said, now if you want a small buffer that isn't allocated from a chunk of something else, go ahead and create a new slow buffer and then copy over the data, right? So like one semi-common issue I see when people are screaming memory leak is that like they get an incoming connection or incoming data, they just want like a slice of that data, so they like slice that data out and they keep a slice of that data around. Unfortunately, since slice like points to the previous data, it'll keep the whole chunk around. So they're like, but we're only retaining like 10 bytes at a time here. It's like, yeah, but each one's a meg in size, so you keep around each one of those. This way you can just like do new slow buffer size you want and then copy out the slice. That way you reduce the size of the total amount of memory that your application's using to prevent any memory leaks. Well, I prefer to call them undesired memory retentions because like Valgrind or any other tool will not report it at all because garbage collection knows about it. Implemented a generic read-write uint. Oh man, I should have put LEBE at the end. But basically, you pass in the number and then this place and then the byte length, right? So 1 through 5, 6. Anyway, so now you can do 24-bit, 40-bit, and 48-bit reads and writes. Why you like people do have legitimate need for 40 or for 24-bit. I cannot think of a good reason to use 40 and 48-bit, but it was there, it was simple, it was fast. I said, what the hey, maybe somebody will figure out how to use a 48-bit read or write. So, and then compare is a new method on buffer. Like you can do buffer.compare and pass two buffers, or you can do like buffer instance.compare and pass another buffer. It basically just tells you if two buffers are the same. It's done at a lower level, like at the native level, because it's a lot faster to do it that way than for loop in JavaScript and check all those values. That's just a total pain and super slow. So it's just a little nicety. Now, all right, new API. I made this one. So any issues that you have with it, you can blame me. In fact, I mean, we're not even stable yet, and I've still been receiving issues for this one. But it's cool. It's really cool. Buffer actually uses this now. Before, Buffer would manage the memory allocation itself. That's no longer the case. I created a smaller, SMALIC stands for simple malloc. But basically, all it does is allocate memory to an object, to any arbitrary object. So, like here, we're requiring it, and then down here, we're saying var object, and then we're allocating, like the second argument, technically, you could pass an object of your choosing, which we'll see in the next slide. But here we're saying, I want it size 16 slots of data, and I want it type double, right? Now, people are saying, well, why don't you use a typed arrays? They're so cool. Well, there's one huge advantage, and let me show you the next slide, because you can do it on anything. So say, for example, I want to create my own little image data function, and I want the data on the image to be accessible. Actually, that shouldn't be double. If it's image data, then it's probably going to be like uint32, right? All right, well, I'll change that too. But, wait, rows and columns. Crap, I missed a couple things. All right, I'll change that. But anyway, image data. Say you want to set some properties, say you want to set some stuff on the prototype, like you want to be able to work with it like you do a buffer, so you have a lot of simple methods to access it, but likewise you want to be able to access the data directly on the data index. You don't want to have to do like some .get .set, that's stupid. So this way you can actually pass, here you can see, you pass the this as the actual object the memory is going to be allocated on, and then it just allocates the raw memory directly onto the this of the object. So any arbitrary object. And strangely enough, in JavaScript, everything's an object. So could I pass a function? Yes. Could I pass a regex? Yes. Could I pass an array? No. Because arrays are already checked by index, and so that totally screws with V8's internals, so they say, no, we won't do that. But at least this way, I don't know, it's fun. I hope people use it for like image libraries, math libraries, other stuff like that. Also has some really cool things, like there's actually a free, smalloc.free. So like say you allocate a huge chunk of memory, and instead of waiting for garbage collector to clean up your memory after you, you can actually do .free on it, and then it will just wipe the data. And it'll free the data for you manually, so you don't have to deal with it, or at least you alleviate that pressure from the garbage collector. Question? Yes. Mike? Mike? Hello? Mm-hmm.
Yeah. So I'm not very familiar with why you'd want to do this, so I'm curious, is it just because it's faster to access at a
No,
lower
actually,
level?
this is like 90% of buffer instantiation time. Like, and it was before too. It's just it was hidden in buffer, right? The whole point of this is to give you the flexibility, like you could implement your own buffer class using this, right? But see, with buffer, you're tied down to, with buffer, you're tied with uint8, right? With typed arrays, you can't extend them. Like, you can't inherit from a typed array and extend it with your own methods, right? And still be able to read the data via the array index directly on the object itself.
So the targeted developer for this, like you said, is for people writing libraries for other people to use.
Mm-hmm.
Should be able to allocate large chunks of memory.
Yeah, exactly. Mm-hmm.
So quick question about the interface. So if this was meant as a extensible buffer, right? Why not just create some new interfaces off of buffer and not have like a malloc and free API?
Because that's very dangerous in buffer. I tried it, didn't work. Because remember, you can slice in buffer, and when you slice in buffer, you get a pointer to the original data. But then if you free that data, because of garbage collect, because for performance reasons, we set it up so that you can only view the data one way, and that is from the sliced object to the parent. You can't look back. And so if you free this chunk, there might be slices that point to it, and then you have corrupt memory, right?
So this is like the first instance in Node, right, that we are explicitly allocating and freeing memory?
You
Right.
can, yeah. Yeah, this is the first version of Node that will allow you to explicitly allocate and free memory on arbitrary objects.
Okay, and I guess my question really is about the genesis of this, right? Because it's like a lot of people pick Node because they explicitly don't have to deal with memory management. You should still think about that stuff, but
Yeah.
nobody
Well,
wants to explicitly have to deal with
hence
stuff,
why
right?
buffer, right? Well, no, okay. You don't have to explicitly free. That's the thing. Garbage collector will clean it up for you if you forget. But you can free it if you want, right? It's like a best of both worlds type thing. And it's meant more for like the lower level developers who are like maybe doing FFI or like working with native code to a database or stuff like that, that can work all that magic for you and then hand you a nice pretty interface for it, right? This is meant for like the 0.1% of developers who can make really cool interfaces on top of it.
Okay, I mean, you could also do the same thing with just native modules, right? Like I could write a binary module that's in C that has that's fast.
This Smalek is about 350 lines of hardcore code that took me months to get right.
No, yeah,
It's really hard to do right.
I'm just curious about sort of what, like an example of where it would be useful, and like, I guess, could you give one about like a concrete example of?
Yeah, so I have a statistics library where it allows me to create matrices and then do complex computations on those matrices. Now, a lot of those complex computations on statistical algorithms have already been really well done in C, right? And so instead of porting all that to JavaScript and having it run like 10 times slower, I'm just going to write a slick little native module that just imports their C, calls it on the raw data that's allocated on the object. But this way, I can create my own like statistical library object that has all those methods attached to it, right? So I can do like beta inverse, and it will call internally and use that data itself, right? Or I could create like a big number library on top of it that doesn't use strings or JavaScript numbers. It uses numbers like on the native side.
Okay,
We'll talk more later.
okay.
Sounds good.
Up in the front.
Yeah.
So just to understand this correctly, this is just a way to extend buffers, correct?
No.
No. Okay.
This is this is an underpinning of buffer. Buffer relies on this to function.
Okay.
Like if you look at buffer code, there's a section in it that says smalloc alloc this size of buffer that you requested, right?
Mm-hmm.
So yeah, buffer depends on this. This is even lower than buffer.
Okay. So you're not going to get any of the buffer APIs. Is the whole point, right?
Yeah, exactly.
Okay.
Like this is completely open. You allocate memory on an object, and it does nothing else.
So to rephrase my question, it's a way to extend the underlying behavior of a buffer.
It's a way to create your own buffer.
Sure. Okay. Okay.
Just one last comment.
Yo.
I know we talked a lot about this. This kind of reminded me of my old malloc free, and then we ran around in C and created auto pointers, smart pointers, try to get away from all of that. And suddenly I see this coming back in Node. Do you see smart pointers around this again?
I have no idea what smart pointers are.
Well, something you don't have to do free on, but you know, basically don't corrupt and end up with a core.
Okay, cool. Well, then in that case, it's already there. It's like I never have to run free on this, right? Garbage collector will handle it for me if I forget, but then I can manually do it if I want and relieve that off of the garbage collector.
The scary part is when somebody else runs free on it and you don't know them.
Oh yeah, no. This has a giant warning at the top that says experimental danger. Use at your own risk.
I would expect so.
I feel like you don't even need a. Oh, come on. Making me show off. So this is for objects. What's the relationship between this and the typed arrays?
None.
None. Okay.
Yeah, I mean they're similar-ish. Well, okay, so like a typed array, you can cast to you can say array buffer and give me a uint8 or a uint32, right? So like you can dynamically cast an array buffer to whatever you want. You can't really do that with this. I limited it in scope just to make it simplistic. For simpler use cases, and because honestly, this could be extended in userland. This was just the core functionality needed in order to create buffer, like to do the buffer implementation. And then I wanted to leave it there because the rest would have just been feature creep.
Right on. Makes sense.
Okay, last one, then we got to move on. Running out of time.
Is this memory created on the V8 heap or on
No. No, it's all external. You can allocate to your heart's content or until you swap your computer to death, which I've done many times. So, yeah, none of this is on the V8 heap. Moving on, async hooks. Okay, so async listener, which I've talked about a lot and like said was amazing, it's dead. It's gone. All right. Now, let's make a clarification. Async listener was the user-facing API to a very complex set of code that I wrote that people had disagreements about. So, following the second point, I exposed all the super low-level hooks that will allow everybody to create their own interfaces, and we're hoping during O.12 development, people can start creating their own modules and libraries, and we can see how it's being used, and then we can decide on the API that people will use that is the most used and put that back into core. I mean, my last pull request, sadly, made me cry a little bit and curl up in the field position, deleted 3,000 lines of my own code that I had written like 6 months ago. But it was for the best. And the new API is extremely flexible. And to give a quick example, here's using it. Again, okay, you'll see up here process.binding, that's something you usually don't touch. This is made to be extremely like use at your own risk, or you know what you're doing. You are a developer intending on implementing a prototype interface for this that will eventually go back into core. And I'm sure people will use this and abuse this and put NPM modules out there for you guys to use. But right now, there are just 3 things in there. Luckily also, since it's quote unquote internal, we can extend this during the O.12 stable release because we're only backwards compatible with user-facing APIs, which this technically is not. So here's how to use it from user-facing API, but it's use at your own risk or use as you go. Mic? 2 mics. Anyway, while we're waiting for a mic, what you get here is an init. So the init is called when a class is instantiated that can possibly create an asynchronous event, like a TCP connection or a file system request or anything like that. Those things are instantiated. We call this and we pass you the object. And then you can say, oh, I missed the highlighting on this. I'll fix that. You can say this, and then there's this async queue object you can attach to it. Actually, you should attach to it. And then to that object, you can put in whatever you want. So say you want to uniquely identify every asynchronous request within the lifetime of your application, you can do that, right? And you just attach that to the this, and that's the object that goes through, and then you can track the asynchronous object through its lifetime and see what the heck's going on. The pre and post functions are called just before the callback. Like basically when the request is complete, there's going to be a JavaScript callback called. This is called just before. This is called just after. That way you can set up and tear down any state to help you capture any errors that are going on. Here's how to use it right here. Now, there was an error handler. I removed that temporarily. We will be putting it back in, but I didn't want to delay the O.12 release any more than I already have. So we're leaving it here for now. But I really hope people get to use this, give us feedback, and then we can incorporate this and really create an insanely extensive API for users to be able to debug their asynchronous code.
So does callback here involve event emitter callbacks?
No.
Okay. Is there
No.
any plans for that?
No. This is all super low level.
Okay.
The whole event emitter thing, that would be a separate implementation. This is all this is all at the native level.
Cool.
Yeah, the event emitter thing, that would have to happen in the event emitter library itself. Is there another one? We're good? All right, cool. Moving on. Miscellaneous. All right, so next tick, I don't know if you've ever gotten in this situation, but next tick in 0.10 would scream and whine at you. If you got it too recursive, I said screw that. If you want to starve your application, go right ahead, so I removed that. Also, I made it so, well, basically it cleans up after itself, so you can call it recursively. It won't crash, it won't die, it runs perfectly, it runs smoothly and super fast. So go ahead and starve your applications all you want. There's a new process.on before exit event. I don't know why there's some apostrophe there. But basically what you can do is say process.on before exit, and then you put in a callback. And then say in your callback you say set immediate. What will happen is that internally the node will say, oh crap, they set up a set immediate, which technically means now my application isn't going to exit, so then it will rerun again, right? And then after that's done running, then it will run before exit again. So you could sit there and just like basically it's the analyze state right before your application exits, collect any information, print anything out, and then you can actually exit. Exec, spawn, and spawn, exec, and exec file sync. People wanted that, I think, for tooling, so have fun with it. And then cluster scheduling policies. In other words, round robin has been added. I'm not going to go into all the kernel level details of why the old implementation has its caveats, but now the default implementation is round robin, where if you use cluster, it sets up a whole bunch of processes and then just linearly goes through and assigns new connections or whatever to each new process, right? Now, future of Node. We are working on platform agnostic performance probes, better debuggability, and again, that's also platform agnostic, right? That's part of the async stuff. Also, a lot of work has been put in because it's like, hey, we can do flame graphs on SmartOS. Oh, hey, we can do flame graphs on Linux. Oh, hey, we can do flame graphs on OS X now, but Windows, sorry. But we're working on trying to get that so we can do it on any platform, make it a lot easier for everyone to debug, create a much more comprehensive debugging suite. And then I have pages and pages of things I know need performance tuning, and I haven't touched. I've refrained from touching because that is a rabbit hole, which once I go down, I will not emerge from. So, once 0.12 gets out the door, I'm going to begin visiting those. And the not so official future of Node, new API interfaces options are here, and more are coming, that don't belong in Node. By that, I mean promises and other stuff, right? So, as a follow-up, we want to simplify the API to allow user-land interfaces to be written that don't incur a performance penalty because of forced abstractions. The forced abstractions in this case are streams and event emitter, right? So anybody writing a promises-based interface on top of Node right now still has to go through our streams and event emitter interface, which causes a huge problem because like there's cost to those, right? But then you're adding more cost onto that. And I am not kidding you, I've seen stack traces hundreds deep when people use libraries like async and whatnot because of the number of calls through all these things that have to occur. So what we want to do is simplify the API, give a an API that sits lower to the C and libv level that will allow people to write their own interfaces because no one person can agree. And I'm not kidding you about this. We have people saying like, oh, well, it should return a promise. Oh, well, it should return a gener. Oh, well, it should return this. It's like we can't possibly return everything. That literally is impossible to return everything everybody's requesting. So we want to create a small, simple callback-based, no streams, no event interface, which will allow people to write their own interfaces that do whatever the crap they want, and then we can let the community hash out what the crap interface they're looking for. But at least this way, they won't incur any performance penalty when they do so. All right, that is it.